Good morning students, welcome my channel Bhuloks Mathematics. Last class I have already discussed about some short answer type question from different chapter. Let us come and work out some short answer type question from different chapters. First question, prove that cot inverse 9 plus cosec inverse root over of 41 divided by 4 is equal to pi by 4. How to prove it? Write down question number 11. Answer. Cot inverse 9 plus cosec inverse root over of 41 divided by 4. LHS I am taking. Okay? It is a heterogeneous. First of all you have to bring all in one, either in sine form or cos or tan. So, cot inverse 9 is equal to tan inverse 1 by 9. Write down. Tan inverse 1 by 9. That is one formula. Cot inverse x is equal to tan inverse 1 by x. This is the very important formula. Now, our aim is to bring cosec inverse root over of 41 by 4 to tan inverse. That is the conversion. So, you make one right angle triangle. Okay? By using this right angle triangle, you have to convert cosec inverse 41 root over divided by 4 to tan inverse. Cosec means h by b. H is here root over of 41. P means here it is 4. H is given, P is given. B is found out. B square minus 1. Okay? Here it is 4. Here it is 3. 4 square. Here it is 4 square. 4 square. 41 root over minus 16. Here it is 25. That is 5. Okay. So base is coming out 5. H is given. P is given. B is found out. This square minus 4 square. By using Pythagoras theorem, 41 minus 60, it is 25 root over, that is 5. Now our aim is to convert this as a tan inverse. So write down tan inverse P by B. P is here 4, B is coming out 5. Okay. So cosec inverse root over of 41 by 4 will convert it to tan inverse 4 by 5. Now we have to use tan inverse x plus tan inverse y. What is the formula? Write down tan inverse x plus y divided by 1 minus xy. This is the formula. Okay? Tan inverse, write down tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. Applied this formula. So simplifying, here it is tan inverse LCM 945. Here it is 5 plus, here it is 36. So 45 minus 4 by 45. 45 cancel. Tan inverse, here it is 41. Here it is also 41. 41 cancel. Tan inverse 1. Okay? Whose value is 1? Tan whose value is 1. So that is tan inverse tan pi by 4. tan inverse of tan box is equal to box. It is pi by 4. So it is RHS. So this is the answer of the question. Okay. First of all, you have to bring the heterogeneous inverse trigonometric function to a homogeneous inverse trigonometric functions by using the triangle, right angle triangle. Okay. So this is the technique by means of which all inverse trigonometric functions can converted to all type of inverse trigonometric functions. So this is the answer of the question number 11. Now we have to discussing about the question number 30. Write down. Question number 30. If cos y is equal to x cos a plus y, then prove that dy dx is equal to cos square a plus y by sin a. So write down, how can you prove it? Cos y is equal to x cos a plus y. So what is x? X is equal to cos y divided by cos a plus y. Now we have to differentiating on both sides with respect to y. Differentiating, write down. Differentiating on both sides with respect to y. So dx divided by dy, dy of cos y divided by cos a plus y. Okay, using division formula, it is u, here it is v. What is the formula? Write down. Formula is v. V means cos a plus y, derivative of cos y, v derivative of u minus u, derivative of cos a plus y, where a is a constant, divided by v square cos square a plus y. Okay, so derivative of cos y with respect to y, that is minus sin y. Write down, minus sin y into cos a plus y minus cos y, derivative of cos a plus y is minus sin a plus y into derivative of a plus y, that is minus sin a plus y into derivative of a plus y. Chain rule is applied here. Divided by cos square a plus y. Cos square a plus y. Okay. So now we have to apply dx dy is equal to minus sin y cos a plus y. Here it is minus minus plus sin a plus y into cos y. Here derivative of constant 0 or derivative of y with respect to y is 1, divided by cos square a plus y. Sin a into cos b minus cos a into sin b. Sin a minus b. Apply. Sin a cos b minus cos a sin b. Sin a plus a minus b, a plus y minus y, divided by cos square a plus y. Y cancelled. Okay. So dx divided by dy is coming out this reciprocal dy by dx is equal to cos square a plus y divided by sin a. So this is the answer of the question number 13. Okay, very important question, must come in examination. Okay, now our aim is to find out question number 14. F is a mapping from R to R defined by fx is equal to 2x minus 3 is bijective. Find its inverse. Bijective means a function fx is said to be bijective if it is injective as well as surjective. That means f is 1 1 as well as on 2. Then we say that f is said to be a bijective function. First of all, we have to check injective, then surjective. If both two conditions satisfied, then we say that f is bijective. Write down question number 14. First of all, we have to check 1 1. Write down 1 1. 1 1 is otherwise called as injective. What is the definition of injective? fx1 is equal to fx2. That implies x1 is equal to x2. So write down for all x1 and x2 belongs to R, fx1 is equal to fx2. Okay, fx is equal to 2x minus 3. What is f of x1? 2x1 minus 3 is equal to 2x2 minus 3. So minus 3 cancel. 2x1 is equal to 2x2. 2 cancel. So that implies x1 is equal to x2. So we concluded that fx1 is equal to fx2. That implies x1 is equal to x2. So if mapping from R to R defined by fx is equal to 2x minus 3 is 1 1. 1 1 property is satisfied. Then onto means surjective. Surjective, write down surjective. For surjective, let y is equal to f of x. Y is equal to f of x. That means fx is equal to 2x minus 3. So always find out the value of x. For surjective, you have to always find out the value of x. So 2x is equal to y plus 3. X is equal to y plus 3 divided by 2. Okay, we know a function f a to b is said to be onto if for all y belongs to b there exists at least one x belongs to a such that f of x is equal to y. So here you will see for all y belongs to R, for all y belongs to R, for all y belongs to R there exists at least one x belongs to R such that f of x is equal to y. Write down the statement. For all y belongs to R, there exists, this is the symbol for there exists, at least one x belongs to R such that f of x, that means f of x means y plus 3 divided by 2 is equal to 2 this y plus 3 by 2, okay, minus 3. 2 cancel, 3 cancel, that is y. F of x is equal to y. Hence, f mapping from F is a mapping from R to R defined by f of x is equal to 2x minus 3 is on 2. Okay, it is on 2. So f is 1 1, f is on 2. Hence, f is bijective. Write down. F is a mapping from A to B. Hence, f is a mapping from R to R defined by f of x is equal to 2x minus 3 is bijective. When a function is bijective, at that time whose inverse exists. So write down f of x is equal to y. So that implies x is equal to f inverse y. So f inverse y is equal to x. Value of x is coming out. Y plus 3 by 2. This is the formula for f inverse y. If question is asking, find out the particular value of f inverse 0. Suppose f inverse 0 is asking question. So put 0 here. 3 by 2. In this manner you have to find out. Okay. So that means f is bijective and whose inverse is exist. That is f inverse y is equal to y plus 3 by 2. So this is the answer of the question number 40. Now we have to work out the question number 50. If A is a matrix 1 minus 2 2 3 1 minus 1, B 2 4 1 2 3 minus 1, verify AB whole transpose is equal to B transpose into A transpose. Transpose of product is equal to product of their transpose taken in opposite order. This is one properties we have to verify by taking one example. Write down A. Answer question number 50. A means 1 minus 2, it is 2. 3 1 minus 1. How many rows? 2 rows. It is 3 columns. This is a matrix of order 2 by 3. B is given as 2 1 3 4 2 minus 1. Here how many rows? Here it is 3 rows and 2 columns. So when number of column of the first matrix is equal to the number of row of the second matrix, then matrix multiplication is possible. Matrix multiplication is only possible when number of column of the first matrix must be equal to the number of row of the second matrix. Now defining AB, write down AB 1 minus 2 2 3 1 minus 1. Here it is 2 4 1 2 3 minus 1. Multiplication, first row multiplied with first column, 1 into 2, write down 2, minus 2 into 1, that is minus 2, 2 into 3, that is 6. First row is multiplied with first column, 1 into 2 plus minus 2 into 1 plus 2 into 3. This is the first entry of AB matrix. Then first row is multiplied with the second column, 1 into 4, minus 2 into 2, that is minus 4, 2 into minus 1, that is minus 2. Okay. Next we have to multiply second row with first column, 3 into 2, it is 6, 1 into 1, here it is 1, minus 1 into 3, that is minus 3. Then second row with second column, 3 into 4, it is 12, 1 into 2, it is 12, 2, minus minus, it is plus. Okay, 2 minus 2 cancel, 4 minus 4 cancel, that is 6, Here it is minus 2. Here it is 6 plus 1, 7. Minus 3 is 4. Here it is 12 plus 2, 14 plus 1, 15. Okay? AB matrix is coming out. Then we have to find out its transpose. Transpose means AB whole transpose. The transpose of matrix is obtained by changing the corresponding rows to corresponding columns. When rows are changed into columns and the columns are changed into rows correspondingly, the matrix obtained is called as a transpose of matrix. So here it is first row, that will be first column. Row, it will be column 6 minus 2. Here it is second row, that will be second column. So here it is AB whole transpose is coming out. Now our aim is to find out B transpose into A transpose. B transpose means write down B transpose into A transpose. B transpose. Here it is B transpose. Rows are changed into columns and columns are changed into rows corresponding. First column will be first row. Second column, that will be 4, 2, minus 1. Okay? First row, first column will be first row. Second column will be the second row. Then A transpose. A transpose means here it is first row, that will be written in first column. 1 minus 2, here it is 2. 3, here it is 1 minus 1. So here, what is the order of the matrix? Number of row is 2, number of column is 3. Here it is number of row is 3, number of column is 2. Number of column of the first matrix is equal to the number of row of the second matrix. So the matrix multiplication is possible. So how can you multiply it? You see here, first row multiplied with first column. 2 into 1, 2. 1 into 2 minus 2. 3 plus 2, it is 6. Okay, first row, first column. First row, second column. 2 into 3, it is 6. 1 into plus 1. Here it is minus 3. Okay, then second row, first column. 4 into 1, it is 4. 2 into minus 4. Here it is minus 2. Then second row, second column. 4 into 3, it is 12. 2, it is 2 into 2 minus 1, it is plus 1. Okay, 2 minus 2 is cancelled. 2 minus 2 is cancelled. So we get 6. Here it is 6 plus 1, 7. Minus 3 is 4. 4 minus 4 cancel, that is minus 2. Here it is 15. You see here B transpose into A transpose. AB whole transpose 6, 4 minus 2, 15. B transpose A transpose is coming as 6, 4 minus 2, 15. So AB transpose is equal to, write down, AB whole transpose is equal to B transpose into A transpose. It is verified. It is verified that the transpose of product is equal to product of the transpose taken in opposite order. So this is the ways you have to multiply two matrix. Matrix multiplication is only possible when the number of column of the first matrix must be equal to the number of row of the second matrix. Otherwise, matrix multiplication cannot be possible. So this is the answer of the question number 50. Now, let us discussing about one important question from the linear programming problem. Find the feasible solution of x plus y less than equal to 1, 2x plus 3y is less than equal to 6, and x greater than equal to 0, y is greater than equal to 0. So how can you do it? Write down the question number 12. First of all, you have to convert the inequalities in the set of constraint, into equalities. Okay? First of all, you have to convert the inequalities into equalities. Here the inequality is 1, another inequality is 1. Equality. So x plus y is equal to 1. Another is 2x plus 3y is equal to 6. So now you have to draw one box. X, it is y. When x is equal to 0, for first line, x is equal to 0, y is 1. When y is equal to 0, then x is equal to 1. For points on x-axis, putting y equal to 0. For points on y-axis, putting x is equal to 0. Then for this line, you have to make one box. Here it is x, here it is y. Put x is equal to 0. When x is equal to 0, 3y is equal to 6, y is equal to 2. When y is equal to 0, y is equal to 0, 2x is equal to 6, x is equal to 3. Okay? Now we have to draw the above two lines in two-dimensional plane, that is in graph paper. Okay? So you have to think it is one graph paper. So it is the x-axis, xo, x dash, y, o, y dash. So it is 1 unit, here it is 2, here it is 3, make it. Here it is also 1, here it is 2, here it is 3. For first line, when x is equal to 0, y is equal to 1. So you mark here, one circle. When y equal to 0, x is equal to 1. So join these two points by using scale. Join these two points, we get the corresponding line. X plus y is equal to 1. Okay? Then when x is equal to 0, y is equal to 2. And when x is equal to y is equal to 0, x is equal to 3. So this is one point on x-axis, this is another point on y-axis. Join these 2 points by using scale. Okay? By using scale, you have to join these 2 points. So that is line 2x plus 3y is equal to 6. Now, considering the inequalities, write down step. Considering the inequalities in the set of constraint, constraints, half planes are drawn. Which is indicated by arrow mark. Okay? Considering the inequalities in the set of constraints, half planes are drawn, which is indicated by arrow mark. Here, origin is here. For first line, origin is here. So put x 0, y 0. 0 less than 1. Satisfied. Hence the arrow goes towards the origin. This is the solution. Okay? This is the solution. Origin satisfied. If origin satisfied, so the arrows will be coming towards the origin. Okay? So for the second line, x 0, y 0. Put origin is here. X 0, y 0. So the arrows will be towards origin. Okay, towards origin. This is the region towards origin. Okay, now considering the haploids and non-negative restrictions, we get a common region called as a feasible region. Write down considering write down. Next step, considering the haploids and non-negative restrictions, we get a common region called feasible region or permissible region, which is indicated by shadowing, SHA, shadowing. Okay, considering the half planes and non-negative restrictions, we get a common region called as a feasible region, otherwise called as a permissible region, which is indicated by shadowing. So non-negative restrictions, x greater than equal to 0, y greater than equal to 0. So you have to mark these arrows here and y is here. Okay, so this person goes towards, what is the common region? So this is the common region which is indicated by shadowing. This is the feasible region. This is the, it is A, it is B, it is O. OAB, this triangle form a feasible region of the given LPP. Okay, thank you to all for watching my videos. Please subscribe my channel, like my channel and share my channel.